said, we went over a lot of the terminology, talked a little bit about the regulations that govern. And what was the general name that we had for the regulations that govern transportation of hazardous material? The acronym, 3 letters. HMR, Hazardous Materials Regulations. Hazardous material regulations apply to all types of hazardous material transportation. What is the class for radioactive material in the HMR? 7. That's right, thank you. Class 7. So anytime you're dealing with hazardous material regulations, from a radiological standpoint, Class 7 ought to kind of catch your eye because that is where you go. A lot of times you'll see requirements and it'll say, except for Class 7. And that just, okay, that doesn't apply to me. And usually along with that, except for Class 7, it'll say, which are handled in accordance with, and it'll give you a section that you need to go to for the radioactive material. What was the Code of Federal Regulations that deal with transportation, or it really is the hazardous material regulations? 49 CFR, that's correct. 49 CFR is the governing document for Code of Federal Regulations. There was another one, though, that we mentioned, and we'll see tonight. It deals with some very specific packaging. What was it?
10 CFR.
10 CFR
61.
Part 71, that's correct. 10 CFR Part 71 is the NRC regulations for shipping. They actually work together. They've got a division of authority, if you will, for radioactive materials. And what you're going to find out tonight, as I said, there's a very specific packaging that's governed by 10 CFR 71, 49 CFR. Rolls back over and says, for these, they're taking care of it in accordance with 10 CFR 71. So they have a pretty good system worked out there as far as taking care of the packaging. But by and large, everything else falls under the purview of 10 CFR or 49 CFR. One of the key factors when we were talking last time, we introduced 2 forms of radioactive material that we deal with. What were they?
Special form normal.
Special form, normal form. Special form, normal form. And a few words. How can you distinguish between special form and normal form?
It's not special, it's normal.
That is a correct statement. And in fact, that's kind of what the regs say. So let's talk about what is special. What's special about special form? It's encapsulated. And it has a minimum dimension. Anybody remember what that dimension is? 5 millimeters. Got to be have at least one dimensions greater than 5 millimeters. So it's encapsulated. It's encapsulated in a housing that you cannot disassemble. It has to be, to open it, you have to destroy it. And it has a minimum dimension of 5 millimeters. Give me an example of a special form radioactive material.
Compressed gas bottle.
Start it back here.
Compressed gas bottle.
Compressed gas bottle, no.
Radiography source?
Radiography source. Okay? A radiography source.
Neutron source?
Some neutron sources, they would, yes. They would be, it's a sealed source. It would be a sealed encapsulated source. It'd have to be destroyed to get it open. So that's, I'm sorry?
No.
So that's special form and normal form. Normal form is anything that's not special form, just like Robert said. And that really deals with most of what we mess with. It would be normal form. And that's just loose debris, anything from loose debris to discarded components, you name it, it probably falls into it as far as normal form. From that, we went in and looked at how do you determine really if it's radioactive material by definition. Yes,
Real quick, did you say 5 millimeters or 5 centimeters on this?
5 millimeters, I think.
Okay.
Is that what the note said? Yeah,
I
5
thought it was
millimeters.
2 centimeters.
As far as quantities, there were specific values assigned for normal form and special form. They were activity values with subscripts. Okay? A1 applies to what? A1 applies to special form, A2 applies to normal form. There are tables. It's listed by isotope. If it exceeds the quantity that's on the table, then it is by definition a normal form or a special form radioactive material. That value, you also need to know, it'll come into play tonight when we get to packaging. That value, that A1, A2, is the maximum value that can be contained in a Type A package. Okay, so that's also a restriction on the Type A package. That's a maximum activity that can be put into a Type A packaging. So keep that in mind when we get to and start talking about the Type A packaging. We also introduced the concept of accepted quantities, and these are values less than the A1, A2 values. That's on the low end of it. But then we also looked at on the high end of it, and there was a HRCQ. What's that stand for? Okay. Highway route controlled quantities. That's for a shipment that has, what is it, 10,000? 3,000 times the A1 and A2 value, or 27,000 curies, whichever is less. So that's kind of stands the gap. That gives you the spectrum there. Accepted quantities on one end and highway route control quantities on the other end. And then we introduced a couple other concepts, and that was LSA, low specific activity, and surface contaminated objects. Within each of those there were subcategories, 1, 2, and 3 I think for LSA, and 1 and 2 for SCO. And there are specific activity levels associated with each of those. You need to be familiar with those. What's the difference between a LSA and a SCO? Let me ask you this, what's an SCO? It's a surface contaminated object, so describe it for me.
It's not radioactive.
How does it vary from an LSA?
It's not
I just say not
radioactive. It's not radioactive, but it
Okay.
has ran.
It's really not radioactive, right? SCO, it's got radioactivity in it or on it that causes it to appear to be radioactive. On the other hand, an LSA has within it, inherent to it, radioactivity, such as resin. That's probably the best example, spent radioactive resin. Whereas an SCO would be a barrel of contaminated laundry. The coveralls themselves are not radioactive, but it has contamination on it. And we talked a little bit about the regulations associated with each of those as far as the limits. And I would suggest if you're familiar with the limits for SCO as well. And so that kind of brings us up. Oh, I'm sorry, there were a couple others. Fissile, and we will talk a little bit more about that tonight because of the packaging requirements for that. and that is anything that is fissionable. Plutonium 239, 241, uranium 233, 235, or any combination. So that does bring us into packaging. Packaging is kind of an interesting thing. We've introduced it already, as was said tonight already. But fundamentally, you need to understand this. And that is this premise, that safety in transporting radioactive material depends on the use of proper packaging for the type, quantity, and form of radioactive material to be packaged. So for an item to be safely transported, it really does hinge on the packaging material or the packaging that's been selected for it. And the design is performance oriented. By that it means that depending on the type of packaging that we're talking about, it has specific design specs that are based on the ability to withstand certain performance criteria or display certain performance criteria. And you'll see what I mean. For each type of packaging that we're talking about, there are testing requirements. The more hazardous, the more radioactive a packaging is, or the contents of packaging is, the more stringent the testing requirements. And you'll see that as we get into it. But that's two important things to understand about packaging. That it depends on the safe transportation of radioactive material, depends on the proper selection of the packaging, and that the packaging has and is designed for performance based. It is the primary means of providing safety. And the more hazardous the material is, the more stronger the packagings will have to be. And here's a very important distinction. You got to catch this. So listen to this. In HMR, package, the word package, when you see that, means the packaging and the contents as presented for shipment. So when you hear that word or read that word package, that means everything. That means the box, that means the stuff that's inside the box, that means any shoring or bracing that goes with it, that means the container that the material itself is contained in, and that means the material. Everything. That's the package. Total deal. Whereas for radioactive material, packaging means the assembly of those components necessary to ensure that there's compliance with the packaging requirements of the HMR. So it's the stuff, it's the container, it's the packing material, it's the things that go into, but does not include the radioactive material. Important distinction. Because the regs do refer at times to package requirements versus packaging requirements. As far as the packaging itself, it can consist of a lot of different things. You can see them listed here. One or more receptacles, absorbent materials, spacing structures that go within it, thermal insulation, the shielding, if it's an integral part of it, service equipment for filling, emptying, bending, and pressurized or pressure relief. What you'll see on some of these, especially the more higher integrity packaging, is they have to have pressure relief provision made so that it won't overpressurize and damage the package or packaging. And so you may have a little safety relief valve on it. That safety relief valve becomes part of the packaging. And when it gets put all together and placed on the conveyance, then it's also part of the package. Devices for cooling or absorbing mechanical shocks. Some of it's very elaborate. They'll have the little shock absorbers built into the packaging. Those little shock absorbers are part of the packaging. And when everything's buttoned up and put on conveyance, they become part of the package. The conveyance, and when I'm saying conveyance, that means whatever's transporting the package. Whether it be a truck, or a seagoing vessel, water-going vessel, a rail car, an airplane, they're all conveyances. But the conveyance itself, the tie-down system, auxiliary equipment, may sometimes be designated as part of the packaging. And that really is dependent upon the type of packaging that we're talking about. When we get to talking about type B packaging, you'll see that and use this word, it's a package deal. Everything that goes into making that package, including simulated contents, has to be tested. And if it's part of a rail car where it's built into the rail car, then that rail car is part of the packaging. It's the conveyance, but it's part of the package. And you'll see what I'm talking about when we get to the certification requirements. We're going to look at several different types of packaging. We are going to look at exempted package, and you'll see I use the word packages here because we're going to take the packaging and the contents together. Industrial packages, which are designated IP 1, 2, and 3. Type A packages. Type B packages. Fissile material packages, and then packages containing uranium hexafluoride. Special case there. We'll talk about those. We're going to look at each one of these and what goes into them. Let's start with low end, and that would be accepted packages. Accepted packages, as you might suspect, contains accepted quantities of radioactive material. And if you'll recall, that's the low end. It's a very, very low hazard, low risk. Usually limited quantity of radioactive material for radioactive instruments or articles manufactured from natural depleted uranium and thorium. And also included in that would be empty packagings. And if it is an accepted package, then it is exempted from some of the requirements of the HMR, or accepted from some of the requirements. They're not required to be tested. This is the one category that doesn't have to have any kind of testing done. They just have to be designed to where they can withstand the normal expected transportation accidents. But even then, it's accepted, it's acknowledged that they may actually release some of the contents under a normal accident condition. But because we're dealing with such a low level and low hazard, it's not as big a deal. I mean, it's still a big deal. But that's why the limits on accepted packaging, or accepted packages, is so low. And that's just a statement of that. Severely limited the contents. You get a standard of safety comparable to that of more robust packages and commensurate risk associated with it. They are accepted from the required marking, packaging, labeling, and shipping paper requirements. They're not as controlled. When we get into some of these other ones, you'll see that there are some we won't get there tonight, but there are some very specific ways that you record the proper shipping name. There is once you've identified the proper shipping name, there is a unique United Nations identifier number that's given to it. There are specific, very distinct markings that are required, as well as labeling, and some very strict shipping paper requirements. But all of those are waived for an accepted package. Except, as you can see, the UN identification number, that's still required. But because it is defined as radioactive material, it does have some regulations that govern this movement for transportation. And I'll just put that in there if you want to later go and look and see what the little link there shows you as far as general packaging requirements and such. You can go take a look. The requirements for them, they have to meet general design requirements as in that previous section. And really, it's very, very loose general design requirements. We'll take a look at them later. But the outside of each package must be marked with the 4-digit UN and the UN number. If you go to this 172-101, is probably a good number for you to remember because that is a hazardous materials table. And let me just go there real quick so you can kind of get a feel for the type of information that's provided there. You can read all this upfront stuff later, but it basically tells you what's in each column and any restrictions on its use. All right, that's not going to cooperate. On the table, there are several columns. It starts with a listing of by isotope and by type of material. And ultimately, you get down into the body of the table to the R's. It's alphabetical. You get to the R's, and there's a list of about 15 descriptions of radioactive material shipments. And they're very specific, like for example, and these are the proper shipping names, or PSN, proper shipping name. For example, it may say radioactive material, low specific activity 1. That would be the proper shipping name for a shipment that would meet the criteria for LSA 1. It may be that it's a accepted quantity. And so it would say radioactive material, accepted quantity. That would be the proper shipping name. Let's see if we pull down there. Yeah, there we go. But you can see it's everything. It's all kinds of different listings, fireworks, fuses. Keep in mind, this is hazardous material regulations. It's everything, including radioactive material. So if you get down into the R's here, R's. You can see it starting right here. Radioactive material accepted packaging articles manufactured from natural uranium, depleted uranium, natural thorium. That is the full proper shipping name. And then here you'll see the class, the 7. That's the class of hazardous material. And then the UN number. That's the UN number is talking about for exempted quantities. Accepted quantities. So we would have to find the accepted quantity right here. These are all accepted quantities, the first 3 here. 4, okay, really the first 4. So for whatever it is that you're shipping, you would pick the appropriate accepted quantity one, and that would become your proper shipping name. And then you would come over and select the appropriate UN number. For accepted, that's the only thing that's got to go on it, is the UN number. But as you go across, you can see there are some other columns, and we're not going to really spend any time on those today. But you can see the packaging, and there are exceptions to it, special provisions, label codes, quantity limitations for aircraft, rail, cargo aircraft, passenger aircraft, bulk, vessel storage requirements. There's even restrictions on storage aboard the conveyance itself, especially in the case of airlines or vessels, shipping vessels. But back to what we were talking about, we're talking about accepted quantities. And so for it, all we need is the UN number. You also need to do a survey to show that your non-fixed contamination levels do not exceed the limits as shown here. And those are the same limits that we talked about previously. They'd be non-exclusive use. And then radiation for accepted quantity. Accepted packages, radiation level at any point on the surface must not exceed 0.005 millisieverts per hour, and that's 0.5 millirem per hour. Very low dose rate. Very, very low. So contact, less than 0.5 MR per hour. And if it meets the requirement for limited quantities, then the outside of the inner packaging, or if there's no inner packaging, the outside of the package itself has got to have the word radioactive on it. So far on the outside we've got radioactive and we've got the UN number. That's what goes on the outside. Limited to 0.5 MR per hour on contact. See this? Packages on the package. So that's everything together with it put together like it's going to ship as presented for shipping. And that's when you take your dose rates. If it's an accepted package that is an empty package, then you have to have the additional posting of empty on the outside. Or labels. If it is an instrument or article, then the radiation level at 4 inches from any point on the surface of the unpackaged instrument, okay, of the unpackaged instrument cannot exceed 10 MR per hour. So you have to do a dose rate on whatever you put inside of it. I wouldn't worry too much about that one. What we're really concerned about is the dose rates right now on the outside of the package presented for shipment. But that is an additional requirement if it's an instrument or article. Here's an example of an accepted package. Smoke detector, UN 2911, and if you look at the table, you'll see 2911 is accepted instrument and articles. The maximum dose rate on either one of those smoke detectors would be 10 MR per hour on the smoke detector itself, at 4 inches from it actually. But what's the maximum dose rate on the package? 0.5 MR per hour. 0.5 MR per hour accepted package.
So, earlier you said it has to say radioactive on the outside.
Yeah, I think that's actually the inner package. This
Okay.
must have an inner package.
Okay.
If it has no inner package, then I think you have to have the radioactive on the outside. Let's see what that says. Yeah. Outside of the inner package, or if there is no inner package, the outside of the package itself. So the fact that it didn't have one would tell me there's an inner package.
So, for those, like each one of those individual smoke detector boxes probably says
Probably says
radioactive.
radioactive. Yeah. Probably does. Other questions on accepted packages? Got a question, Rob?
When you go to buy a smoke detector, have you ever seen them have it?
I'm sorry?
Whenever you go to buy a smoke detector, have you ever noticed? I've never bought one. Have you ever noticed one on the packaging of a smoke detector?
It says radioactive.
It does?
And if you look on the back of it, it
Yeah.
has a little tray full of it. It says radioactive material, do not open, dispose of properly in accordance with, and I think it has the regulations says.
It's a really small dose rate, right?
Oh, yeah. The sources on smoke detectors anyway, americium-241 usually. Alpha emitter,
Yeah.
but it's a special form. Well, it can't, not really a special form. You have to destroy the smoke detector to get to it, but you can do it.
So if you change out your smoke detector in the house, is it like very bad to just throw it in the trash? Or it says dispose of properly and everything,
It
but
tells you how to dispose of it, it gives you the reg.
oops.
Well, it's just like a fluorescent light bulb. Seriously. Fluorescent light bulb's hazardous material. It contains mercury. It tells you just dispose of it as hazardous waste. So if you drop a fluorescent light bulb in your home, you've got a hazmat situation. Remember what you buy. Put them in your house. Seriously, I mean, you've got a hazmat incident scene because you've got mercury. Any other questions on accepted packages? All right, let's move up then. We're going to talk about industrial packages. That's kind of the step up. They are classified as IP. They may be used with LSA materials and certain SCOs. There are 3 categories, 1, 2, and 3. And you can go to this link and it gives you the specifics of each one, but basically it's increasing level of hazard. IP1 not as hazardous as IP3. But basically, in general sense, IP1s have to meet the general packaging requirements. That's one of those umbrella general packaging requirements. Most of them have to meet that to begin with. And equivalent design requirements to accepted packaging. So they have to meet the general and also accepted. So that tells you an IP can be used as an accepted package. Okay, so a higher one, as long as it meets those requirements, can be used to ship a lower hazard material. And that's the way the regs, all of them work, for the most part. IP2s have to meet the general, and when subjected to a free drop and stacking, and the Type A packaging test, are evaluated against these tests by any of the authorized means, each IP must prevent the following. Don't worry too much about all that, but basically what it's telling you is it's got to meet the general design, it's got to be, it's got to meet the free drop and stacking test, and they've got to prevent the following things. Cannot lose or disperse the radioactive contents. So they have to maintain the integrity of the package. And any significant increase, it's got to prevent any significant increase in radiation detection, either recorded or calculated on the external surfaces of the condition before the test. It's pretty interesting, some of the tests that they do, and I've got some graphics here that will show you some of the tests, including the free drop and stacking. Basically, the free drop is it's got to drop from a certain height, just simply boom. And the height is specified. The stacking basically is it assumes that your package is the bottom package in a stack of items. I think it specifies like 3 items of equivalent weight, so 3 times its own weight. It's got to not be crushed, and it's got to prevent these things. And IP3 got to meet the requirements of 1 and 2, and also the additional requirements that are in this section. And basically, that is the Type A testing. So in essence, an IP3 is equivalent to a Type A package, or Type A packaging. So it being the higher of the 3 IPs, basically is bridging the gap over into a Type A package because it meets all the requirements. Give you an idea, the green box is the IP. It's on I think it's on a rail car here. That's an IP2. And really an IP3 doesn't look any different. It just has been tested to a higher design criteria. So that's accepted packaging, and that is industrial packaging, 1, 2, and 3. And the next one is Type A packaging. And we'll get this done and then we'll take a break. Type A packages. Type A packages must maintain their integrity under conditions of normal transport. And it is assumed that it may be damaged in a severe accident and could then release some of its contents. Severe accident. We're talking about major accident. Therefore, they limit the maximum amount of radioactivity in a Type A package, and we said this earlier, is limited to the Type A quantities, and that's the A1 and the A2 values. A1 for special form, A2 for normal form materials. So the maximum amount of any radioactivity is permitted in a Type A package is the Type A quantity, and that's synonymous with A1, A2, depending on which form. Got to complete or comply with the general packaging requirements, and additionally the Type A packaging. And this 412 and 415 basically contains these items. It says it's got to prevent the loss or dispersal of radioactive content, got to maintain the radiation shielding properties of normal conditions of transport, which include rough handling conditions. And it even tells you what rough handling conditions mean. Falling from a transport vehicle or handling equipment, in other words, off of a forklift, falling off the forklift. Being struck by irregularly shaped freight or other packages with sharp corners. Sitting on an uncovered loading dock during inclement weather. And having heavy freight loaded on top of the package. So it's got to withstand all of those. That's considered rough handling conditions. Now, the thing about Type A packaging is the individual shippers must make their own assessment and certification of the package design against the performance requirements. And what that says, that is, if Jerry's in the shipping business and he's going to ship a Type A radioactive material, he picks a box or something to ship it in, he's got to assure, as the shipper, he's got to assure that all the testing requirements for Type A packaging have been met. And how he does that's up to him, as long as he meets all the requirements of the regs. And we've got I think this is a little, there we go. This is a little PowerPoint that's put together by a gentleman that's with the Health Physics Society that shows how he went around doing his certifications. This gives you a real good feel for Type A package, actually packaging and package as a concept. It also shows you the different tests. So we'll just flip through this real quick, maybe. There's his package and his packaging. Just a cardboard box. He's got a liner right in here. Yeah, I can't use that. He's got a liner here for not shielding, but cushioning. There's an inner cylinder in which he places his material. There's a cap for that cylinder, and then there's a styrofoam pack that goes on top. All that goes down in here, closes up, and that is the package once the material's in it. Without the material in it, this is the package. Okay? I'm not going to worry about this. Okay, here's the performance testing. First thing you got to do, first performance test on Type A packaging is a water spray test. And it's got to be the first thing. All these other tests follow after it's done. The water spray test basically is just what it sounds like. Must proceed each test, simulate rain at 2 inches an hour, applied to 4 sides of the package, last for at least an hour, and to allow for maximum soaking without allowing any drying. Whoops. Before we get to that, I got to show you all the pieces and parts, how it goes together. Okay, that's the radioactive material, the black. That's in a glass container there. It's a powder, granular form. It's wrapped up, put in bubble wrap, put inside the inner container. The inner container's got the lid put on it. All of that goes into the cardboard box with the styrofoam on top, or the foam on top, closed up. There is the package. All right. This is what's got to be tested. It's got to be done with the contents. So it's tested as a package, not as packaging, but as a package. Here's the water spray test. It says it there. Unless it runs for an hour. It's got to be equivalent to, what do you say, 2 inches an hour? Yeah. All right. And you can see it's got, I don't know if you can tell it or not, but it's blocked up off concrete a little bit, so it's not necessarily setting in a puddle of water. There's a better shot of it. And then this is the loading testing. This loading testing, equivalent to a force of at least 5 times the weight of the package for at least 24 hours, simulating the damp package being at the bottom of a stack of packages. And in this case, they've just got an equivalent to 5 times its own weight sitting on top of it. And it'll sit there for, and this is after it's been wetted. And you can see it had a little deformation on it. I don't know if you can tell that or not, but it's kind of smushed a little bit, maybe a little bulge here, but it's not lost any contents. And that's what is a criteria. So it goes inside, checks, make sure everything's good there. The penetration test. Penetration test, 13.2 pound, 1.25 inch diameter steel rod being dropped from at least 3.3 feet onto the damp package. It simulates a loose object hitting the package. And here he shows the package just out there at the bottom of the loading dock. He's got his tape measure there measuring it out. Here's his steel rod, and he's going to drop it. And you can see the results. Didn't penetrate it. But the true test again is, how did the contents fare? And apparently they did all right. Those are the performance. Remember I said it's performance based? These are the performance tests that are done on a Type A package. You do not have to get prior DOT approval. You do your test, you document it, it passes, you say so, and you ship it. Packaging with contents must be capable of withstanding the water spray, free drop, stacking, and penetration test. You can take one prototype. In other words, this may be a common one they're going to use to ship, this particular type of sample all the time. Their prototype showed that that package with that configuration and those design specs meet the Type A requirements. So that's all the testing needs to be done. You don't have to do each shipment. Now, if he were to change and use a different manufacturer box or something like that, you have to repeat the testing. And as I already said, the water spray test must precede each test. Just as a reminder, the water spray, left in rain, about 2 inches an hour for a period of at least 1 hour, followed by a free drop test, which I don't think we showed, 1 to 4 feet, depending on the mass, onto a hard surface in the most damaging orientation. Most places just do it in every orientation. Corner drop, flat drop, horizontal drop, vertical drop, bottom first, top first, every orientation that you can imagine. And in the regs, there are additional requirements for, depending on the type of material, that you can do a different drop test. Stacking test, force equal to 5 times the weight of package for 24 hours after the wetting test again. And then the penetration test, 13.2 pound, 1.25 inch diameter steel rod, dropped from at least 3.3 feet onto the damp package. If they contain liquids or gases, there's a few more tests that you have to do. A bit more stringent than the requirements for solids, which is what this was. And you can find those additional tests in these links. You can see the height has been increased to 30 feet, which is considerably more. Puncture test is at 5.5 feet instead of the 3 feet. And there are some other ones that we'll show in there. And these are some common Type A packaging. Type A packages. Fiberboard, wooden box, steel drums, water spray. So that's Type A. We talked about accepted. We talked about industrial packaging. We talked about Type A. The next one is Type B, and we'll take our break and come back and pick that up. Break for, we'll say, be back in here at 20 minutes. Let's continue on. We'll pick up Type B. Hopefully get the packaging done tonight. We should be able to. So we've gone from the accepted, which is very minimally restricted, not much required, no performance testing of it to speak of, into industrial packaging, and then into Type A, where we found that there are quite a few performance tests that have to be satisfied. Keep in mind, again, Type A is the shipper's responsibility to make sure that the testing is done. Now, in reality, what happens is that a shipper, such as a utility, they will buy a tested Type A packaging from a vendor. All right, and that vendor presents the testing, and they accept it or not. The little scenario I was giving you where Jerry's a shipper, he does, or like this guy here, he probably only ships a few of these every so often. And so, and he may have even done this for a paper presentation. Who knows? But you can do it. And it's perfectly legit as long as you document it in accordance with regulations and be able to demonstrate that it did pass. So Type B is our next one. And as you might imagine, it's a little bit more stringent. They've got to meet the general packaging performance standards for Type A, which is in keeping with everything we've discussed so far. The higher one meets the performance criteria for the lower one, and then there's some additional stuff. It also has to survive a hypothetical accident condition, severe accidents. And in doing that, it has to undergo these specific tests. Also, after testing, there needs to be no or very limited loss of shielding capability, no loss of containment, and that is accomplished or is verified by leak rate testing of the containment afterwards, after the testing is done. The thing to know about Type B is that it says most domestic Type B. There's only a handful of domestic Type B packages that have been certified, and they are all certified by the NRC. And this is where 10 CFR 71 comes in. 10 CFR 71 addresses the certification of Type B packaging and stipulates the requirements for that. And if I'm not mistaken, the little certified by the NRC link here is Part 71. So you can click on that and go and take a look at it later. That's what's required. Each design is approved by the NRC, and it is approved and given a certificate of compliance. Once all of the testing has shown that it is satisfactory and meets the requirements of the regulations, the NRC issues a certificate of compliance. The DOT does authorize use of NRC-approved Type B packages, and the standards for their use are contained in the sections that you see here. Also, numerous Type B packages are approved by the DOE. And you will see some of those here. You've already seen some of them. If you'll remember the packages that we looked at for true waste, those two different kinds, those are Type B packages. And they are shipped or approved by DOE under the authority of the DOT. And as it notes here, several of those, including the two that we saw for true waste, are certified by the NRC as well. So they may have multiple certificates of compliance or approval for use. The performance criteria that tests for the hypothetical accident conditions are prescribed in this section of 10 CFR 71. It talks about the following tests, and we're going to talk about the test here shortly. It says here that the NRC regulations include the following tests, which are to be done sequentially, except for the immersion test. So you have to do this, then this, then this, very much like what we looked at in Type A. The wetting one first, and then this. But as it's listed, this is the sequence that they have to be done in. Puts the maximum stress and strain on the equipment. I'm going to go over these, and then I'll come back and I'll show you some pictures of the test. The free drop is a 30-foot free fall of the test package to an unyielding surface. That's an interesting description, but there's a defined construction of this unyielding surface that we'll look at. In a position in which maximum damage is expected. It'll depend on the design of the packaging itself, but in most cases it will be subjecting a welded joint or a seam. It will be the point of impact, because that's the one where you would expect the most damage to occur. You would expect that to be the weakest part of the package system. You also have a crush test. It's a dynamic. Position the specimen on a flat, unyielding horizontal surface so as to sustain this maximum damage. You're going to drop an 1,100-pound steel plate from 30 feet onto the package. 1,100-pound steel plate onto the package from 30 feet. A crush test. A puncture test. It's a free drop of the test package. Okay, the package itself is lifted up to 40 inches, and it's dropped onto a 6-inch diameter vertical steel peg. It has a length that causes maximum damage, be at least 8 inches long. And then you have a thermal test. A thermal. Exposed to a fully engulfed thermal environment of at least 1,475 degrees Fahrenheit for 30 minutes. Hypothetical transportation accident. Worst case basis. And then we're going to put it in water. If it's fissile material, it's got to go under a head of at least 3 feet. And then for all packages, it's got to go on down to 50 feet. And it can sustain no leakage, no air leakage. Well, let me back up and show you some pictures. Okay, this is the drop test, and you can see 30 feet. Okay, it doesn't like me doing it. Switch. 30 feet. And you can see the angle it is, that would be a welded joint there, so it's going to impact there. The unyielding surface, or unyielding target, this is usually a metal plate. In fact, I mean, here we go. Yep. Here's the unyielding surface. It's the 4 to almost 8-inch thick armor plating, sitting on top of steel reinforced concrete, shored up underneath. So it is an unyielding surface. It doesn't move. It doesn't compress. And that's the idea. And so you drop your container onto that. And it cannot sustain any damage. Speed of impact, at impact, 44 feet per second, 30 miles an hour, basically. That's how fast it's going. The crush test. You can see the Type B package here. In this case, it looks to be some kind of 55-gallon drum device, but I'm sure it's not just an ordinary 55-gallon drum. The steel plate, 1,100-pound steel plate, 30 feet, 180-foot drop tower, it says. But it's at 30 feet. Okay. Speed again, at impact, 30 miles an hour. 1,100-pound steel. And it cannot lose its integrity. It cannot be deformed to the point where it would lose any of the radioactive material. And then you have the puncture test. Dropping the package 40 inches onto a 6-inch diameter welded steel spike. You can see the spike here. It's on the unyielding surface, okay, so it's not going to compress either. Distance of 40 inches, and you just release it. Speed at impact 10 miles per hour. And then Place the package 40 inches above a pool of burning fuel for 30 minutes, 1,475 degrees Fahrenheit. It's in there somewhere. And then you stick it underwater. If it's all packages, 50 feet for 8 hours. If it's just the fissile package, then it's 3 feet for 8 hours. And they can simulate the depth. It doesn't have to be at 50 foot. They can pressurize it to an equivalent depth pressure. So you see Type B packaging, why it might be certified. They do a prototype, and these are fully loaded, okay? They're not with radioactive material, but equivalent weight of material, design weight. And the test is sequential. The model, the spec, goes through the test, and then based on the results, it either receives a certification from the NRC or it doesn't. And this just is a pictorial of the test with a quick synopsis to each of them. Now, if the packaging is going to be, or if the package is going to contain more than 10 to the 5th quantities of A2, which high route control quantity might, then it has to undergo some additional testing. See an external water pressure, 290 pounds, less than 1 hour, no collapse or buckle. And here's some pictures. This is Chem Nuclear Services, CNS, they're a waste processing vendor. At one time, they had like the only 3 Type B packaging certified by the NRC that was in use. And this was before the true waste packages came about. But this is a package that would be used to transport solidified resin, for example. A resin liner would go inside this shielded cask. And you can see it's got all kinds of turnbuckles and braces and such, and these overpacks, they're called. With all of this installed, this becomes the package. And that includes the flatbed that it's, or the bed that it's sitting on. So the whole thing in this case is the package. These are the ones you've seen before, the true packs, 1, 2, 3 of them. And just as kind of a snapshot, there's 10 drums inside of a cylinder which sets inside of this. And that is the Type B packaging. The combination would be the package. And then the true 72B cask, the actual cask itself is this piece here, mounted to the rail car, or the truck here, with the overpacks on it. Again, all of this becomes the package because it's installed. It is an integral part of that truck. The conveyance is the package. And then here's one you may not have thought of. Radiography camera. It is a Type B, certified Type B package. You can see it even indicated down here. Type B. Special form. There's the UN number. And then there's some US numbers here as well, which is evidently required for this package. Questions on Type B package? Do you think they're safe?
After all that.
That looked pretty good.
Let's see if I can find it.
It's crazy, man.
We were talking about this one.
This truck is carrying another shipping container. It's a 25-ton cask designed to carry nuclear fuel from generating plants to storage areas. Should something happen to this container, the results could be tragic. Engineers at Sandia Laboratories have devised a test that simulates one of the worst possible situations such a container might encounter. A locomotive powered by 6 Nike rocket motors will be sent down a track at a speed in excess of 80 miles per hour. At the end of the track, the container, mounted on top of a tractor trailer. Indefco accelerometers have been mounted to the container, the truck bed, and to the locomotive. The test begins. The result? Incredible as it may seem, the cask survives the collision without serious deformations.
That's from the Sandia National Labs, which is also where this is from. That does all of this, or a lot of this testing from the NRC. So yeah, I think they're probably safe. If they're properly maintained and used. And that's a key component of these, and that's why there's such really a lot of attention paid to them whenever they are used. Because the improper attachment or improper torquing of the lid or just any number of things can invalidate that certificate of compliance and may actually lead it to not be able to perform as it was designed to do. So there's a lot of attention given to them whenever they are used, that they are maintained properly, including things like that. It has a certain amount of maintenance that's required on it. A lot of quality control things go into its use. And if any time it becomes damaged or inoperable, then the certificate of compliance is withdrawn and it can't be used anymore for Type B material. Questions on Type B? Let's look at fissile and this, and one more I think is, this may be the last one. Packages containing uranium hexafluoride. Both very short. Keep in mind what fissile material is: plutonium-239, 241, uranium-233 and 35, or any combination of those things. Material that is capable of undergoing fissioning. So what would your concerns be with fissile material being shipped or transported? Okay. Possibly terrorists, right? Someone steal it, use it for bad things.
You don't want it to start fissioning.
You don't want to start fissioning, right? Fissionable material has that property, right? So you don't want it to start fissioning. So a lot of the requirements here are geared toward doing that, making sure that you don't wind up with a fissionable quantity in the same location. After we talk about the packages here, we're going to be going into communications and some of the controls, transportation controls. And one of them that we'll talk about is the Criticality Safety Index. And that specifically is geared toward ensuring that you don't get that quantity all in one place where you can get a fission reaction. The fissile material packages are talked about in this section of 49 CFR. And basically it talks about acceptable type A and acceptable type B packaging. Just because it's fissionable or fissile does not mean that you have to ship it in a type B container. In fact, I believe you can ship it in just about any of the categories that we talked about, as long as the controls are in place. But all type A and B are certified by the NRC or by the DOE. There are additional testing requirements in addition to the A and B requirements that will be specified in different parts of the regs. I didn't put those up there. Because there are a lot of them. Really what you just need to know is that there is additional testing that's required in the regs. As far as pictures, here's spent fuel. This is very similar to the one you saw test being run over by the choo-choo train, the rocket-powered choo-choo train. So they found this on a YouTube. Couldn't they get going 80 miles an hour without using 6 drive rockets?
They're just trying to have
They
fun
were
with it.
well. I was assuming it was a
Probably
dead
didn't have
end.
enough track.
It's just a wait for
Rockets were just never good.
Probably didn't have enough track. Maybe enough track to get that thing to build up enough ahead of steam.
Any of y'all watch Mythbusters?
Yes.
They actually use Sandia's rocket sled thing out there for one of their myths. It was pretty cool. Huh?
The car and a half with a snowplow.
Yeah, that was it, yeah. Now, as far as, this is another fissile RAM, but it's also uranium hexafluoride. So we're kind of covering 2 bases with the same thing here. Because uranium hexafluoride is fissile. But this is a inner cylinder in which the uranium hexafluoride is placed. When we get to it here, we'll talk about some of the unique properties of UF6. But then that cylinder is placed inside this shipping overpack. You can see, unlike the other overpacks that just kind of cover the ends, this covers everything you might expect. As far as uranium hexafluoride, it's a radioactive material with, in addition, it's more of a chemical hazard than it is a radioactivity hazard, except for the fact that it's fissile. And so you really have 3. It's radioactive, it's fissile, and it's chemical. During transportation, it exists as a crystalline solid and is shipped in that inner cylinder, maintained a slight vacuum, reduced vacuum. And the reason is because humidity or vapor in the air will react with it. A breach of a cylinder results in reaction with material and moisture in the air, causes a corrosive hydrogen fluorine gas or fluoride gas with moderately radioactive uranofluoride solid particulate. So it's a nasty situation, basically. And so that's why it requires a special cylinder, a special package for uranium hexafluoride. Interesting, though, that under the HMR, radioactive nature of the material takes a precedence and the chemical hazard is treated as a subsidiary risk. And I guess that's probably because of the fissile nature of it. Depending on the degree of enrichment and how much of it that you have, you can transport uranium hexafluoride in any of the packages that we've talked about. Again, it's dependent upon how much it is there as far as enrichment and the actual physical quantity of it. You would still need to meet the requirements of the packaging itself. And if you want to see what the specifics are, you can go to this section of 49 CFR. That pretty much is it as far as packages or packaging is concerned. The next topic and we're going to touch this, and then we'll be finished for this evening, is transportation controls. Of course, one of the biggest transportation controls, as we've already mentioned, is the selection of the right packaging and the proper putting together of the packaging with the contents. But there are a lot of other things that need to be done in the transportation realm that ensures safe transport. And that's what we're going to talk about here. There are some specific things that we're going to talk about. And as we just said, proper packaging is the primary means. And those controls that we're going to talk about now that are on top of packaging includes the use of this thing called a transportation index. Also, as I've already mentioned a little earlier, there's another index that we rely upon, and that's criticality safety index. Obviously, dose rate limits are necessary and important, as well as contamination limits. Also, as a transportation control, we have the exclusive use provisions that we can implement, as well as the use of closed transport vehicles. We're going to cover each one of those as it pertains to controlling transportation of radioactive material. Exclusive use, just for a reminder, is sole use by a single consigner of a conveyance, for which all initial, intermediate, and final loading and unloading are carried out in accordance with the direction of the consigner or consignee. Consigner is usually the shipper, the person that's sending the material. The conveyance is the truck, the ship, the aircraft, whatever means of transportation is chosen. But basically what that says, exclusive use, it's yours. You've consigned it. It's for the express purpose of a radioactive material shipment, and it is yours from the time you load it until the time it's unloaded and returned or released. And so it's exclusive for that purpose. You must ensure that any unloading or loading is performed by personnel having the proper training and the resources for safe handling of the consignment or safe handling of the cargo. There are specific training requirements. This that you're undergoing through this course is a very small fraction of it, but it's a good snapshot into the, I guess, the comprehensiveness of it. But if you, for example, if you get picked up at a power facility and get assigned to the rad waste group, rad waste handlers and R&D technicians have to undergo some specific, very detailed training on rad waste transportation or radioactive material transportation. A lot of what you're getting here would satisfy most of that, but there are still some that we're not pursuing with this course. It also has to provide the initial carrier with specific written instructions. The truck driver, as part of his documentation package, he gets shipping papers, of which there are specific instructions on handling the material that he has, instructions not to stop, and if you do stop, if you have an accident, if you are delayed for any reason and you don't look like you're going to arrive within this period of time, then you've got this number to call, and so on. All that has to go with shipping information, or shipping paper. And with that, we're ready to start talking about the individual things, and we're going to save that for another night.